Okay, so we were looking at reviewing functions a little bit yesterday. And here's where we left off. So how do we interpret this, right? If they give us a function, and this, this is different than the earlier problems that we did. We're not, I gave these to you guys yesterday, is that right? Anybody need one? No? Everybody's got them? Okay. We're not evaluating a function like we were yesterday. Remember, yesterday we were doing things like this. If they gave us a function, p of x and q of x, and they wanted us to do something like 7 minus q of 4.5. So what is q of 4.5? Somebody, let's be real brave here. You guys can speak up here a little bit. What's q of 4.5? What's that mean? It's, say it again. So the 4.5 is x, right? What does that mean if I say q of 4.5? Is that an input or an output? It's an output, isn't it? It's an output number, right? If I input 4.5, that just represents some output number. It's going to be 7 minus whatever number that is. To find the number, we just plug 4.5 into the function q and see what we get, right? So that's evaluating a function. That's pretty straightforward, right? Just plug and chug. This is a little different, right? Let's look at number 13, or how about number 14? If f of x equals negative 62, find x. So that's different. We're not plugging a value in for x now. We're setting the function equal to something, and then we're solving for x. Okay, a little bit more challenging, maybe one step harder, right? So we got to solve this equation. Now we can do this. It's not hard to do. The algebra is pretty easy, right? It's easy to isolate the x. But I want to remind you about our Desmos graphing trick for this. So with Desmos graphing, we can go, if I ever want to solve an equation graphically, I can graph the left side of the equation, call it f of x, right side of the equation, call it g of x, and then see where they intersect. And I don't even, for this purpose, I wouldn't have to call them f of x or g of x because I'm not actually plugging values into the function, right? I could just call them y's if I wanted to, right? The f of x, g of x thing that we did previously, it was really handy to use like we mentioned yesterday, to use the function notation, because then I was set up to be able to evaluate the function, right? Quick reminder, like if I was doing something like this, if I wanted to know what the value of the function, say I have some bizarre function here, square root of x squared minus 37 all divided by the natural log of x plus 2 or something weird like that, some really bizarre function. And I want to be able to plug values in and get outputs. Then I want to use function notation. If I want to calculate f of 10, that's easy to do then, right? That's the advantage of using the function notation. Okay, here I don't really need that necessarily because I'm not really going to be plugging values in. So I could call it y. It doesn't hurt to call it f of x, but it'd be fine just to say y equals, what's my function again? 3x plus 19, okay? Or, being as they use function notation, I'll do it too, doesn't matter. So f of x equals 3x plus 19. And then there's the graph of that thing. Now I want to know when that's equal to negative 62. So I'll come down here and graph y equals negative 62. And then on my graph, all I've got to do is just zoom out until I can see the intersection of those two graphs, right? The green one is f of x. The purple one is the y value that I'm setting it equal to. And there's the point of intersection. So what's the solution? Negative 27, because I'm looking for the x value, aren't I? Right, I'm solving for x. Okay? Okay, give me 1 to 5 on that. How we doing? Okay? Okay, so I want you to try that at least once on the assignment. You can practice using Desmos that way. So there's some notes. There's what we did. All right. So that's it for that stuff. Okay. Tell you what. Well, I'm gonna do a little bit more, but before I do that, I'm gonna have everybody jump in and just do a couple problems on the assignment. I want to make sure everybody's okay with this material. So, jump in. Okay, so let me turn this assignment on. Okay, so you know what? I'm changing my mind here. I'm looking through this, and it's we gotta keep going before I even put it up there. 'Cause I think we need a little practice with some more problems. So, sorry about that. We're just gonna go back to. We'll just keep going with this. Okay. There we go. Okay, so back to business here. So we're going to talk about the part that I think we need a little more practice on is picking out domains and ranges of functions. Okay, so quick review from yesterday. True or false, this graph represents a function. True, how come? Vertical line test, right? I can sweep a vertical line across and it never intersects in more than one place. True or false? False, right? Clearly that's going to intersect over here, isn't it, right? So that one's not going to work. Well, I don't need to move it. You get the idea. Oh, there it is. Right. We see a couple intersections there. What about that one? False. Where's the problem? It's good so far. Good so far, good so far, good so far. But when we get over, clear over to there, we got problems, don't we? Right? There's one set of points that lines up vertically, so therefore it's not a function. Okay, let's look at some examples here. So what about these? So let's take a look at this first one. They want us to find the domain in the range and then determine if it's a function. Okay, so let's look at this first example. The domain is, we're going to use what's called set notation for this, right? So when we want to write a set, we always enclose the elements of the set if it's a discrete set like this, not a continuous. I mean, there's just, how many elements are there in this set up here of points? So I've got this set, and inside that, it looks confusing because there's lots of commas, right? But what is that a set of? It's a set of ordered pairs, isn't it? How many ordered pairs are there? 4. Okay, good. So inside the set, I've got these individual ordered pairs, and notice how we set this up. I've got the script brackets, or the set brackets, that are enclosing all the stuff that's in the set, all the elements. Each element of the set is separated from the others by a comma, okay? So I've really just got a set of 4 ordered pairs there. If we want to write the domain, well, the domain is a set of values, so we need to write it as a set. We're going to use the set brackets. And then I'm just going to look at all the inputs. What are my inputs? -1, 0, 4, and 6, okay? Now, when we write the inputs and the outputs, we like to write them. We don't have to have them matched up vertically or anything. We'd like to write them in an organized way, and so we write the elements of a set in numerical order. So what would the elements of the range be? Well, we got a -9, a -5, a 3, and a -2, and I would just put those in numerical order. Okay, it's telling us it is a function. How come? Each input only has one output, right? So it passes the function test. It is a function. Okay, let's try number 2. So what is the domain? We're going to write it as a set. What's the domain here? Okay, the x values. So if I put them in numerical order, I'm going to get what? Okay, good. Now here's a question. How many, I see a 5 there and a 5 there. How many times do I have to write the 5 in the domain? Just one, right? Just one time. I just want to know what numbers are a part of the domain, and those are the numbers. How about the range? Good. In order, -6, 0, 2, 4. Is it a function? What do you think? Thumbs up, thumbs down? Thumbs down. Good. And we can see there's trouble there right away, can't we? Even if you didn't see the setup there, when you look at the domain and the range, you probably can look at that and say, there's going to be a problem there. How come? Yeah, I've got more elements of the range than the domain, right? So right away that tells us logically, okay, we're going to have problems because at least one of those members of the domain, one element, has to be mapped to 2 outputs, doesn't it? It has to produce 2 outputs. So no, it's not a function. And the reason is those 2 points, right? The input of 5 gives us 2 separate outputs. Okay? How about this guy right here? Domain. This is pretty easy to find the domain, right? What's the domain? Yeah, just that column in numerical order, right? What's the range? That column in numerical order. Okay, so let's look at these then. The domain is -4, 0, 2, 7, right? The range is -1, or -8, -1, 3. So think about that one a little bit. Thumbs up or thumbs down? Is that a function? Okay, I'm seeing a little bit of both. I'm seeing mostly thumbs up. Okay, what potentially might the problem at least at first appear to be here? Okay, I got 2 3s there. Is that a problem or not? No, doesn't matter, right? There's no rule that says I can't have the same output occur more than once. The rule is I just have to have one input or one output for each input, right? Well, there is no input value that gives me multiple outputs. So we're okay. That's okay to do. It's okay that the output of 2 is 3 and the output of -4 is 3. That's okay. It still passes the function test. So yes. Okay, how about this mapping down here? Easy to find the domain and the range when they're written like this. What's the domain? The range? Function? No. And what's the red flag that's popping up here? Yeah, look, I've got an arrow. You can see right away in a mapping that if I've got 2 arrows that are leaving one input, it's not a function, right? Right away. We know that there's only one output for each input, so each arrow can only leave one input, okay? Each input can only have one arrow leaving it. That's what I should say. How about this one over here? Is this a function? It is, right? Even though, is this okay that I've got 2 arrows pointing at the 7? It's fine, right? As long as there's only one arrow leaving each element of the input, yeah, then it's a function, okay? All right, what's the domain of this function? And how would you find it? What's the trick probably to find it the most easily? What do you think? What's the domain? Okay, negative 3, 0, good. 0, 2, 4. How'd you find those so easily? Yeah, you're just looking at vertical lines moving across, and you're trying to find what all the x coordinates are, right? Everybody see that? We just want the x coordinates of each of those points. Those two line up vertically. They have the same x coordinate, okay? What about the range? Bottom to top, isn't it? Just looking at y coordinates. So what are we going to get? We hit that one first, moving from the bottom to the top. What's the y coordinate there? Okay, negative 5. Then we hit this guy. Then we hit this guy. Then we hit that guy. And then we hit that one, which is 4. Function? Nope. And that's easy to tell because, look, those ones line up vertically, right? Okay, how about this one? Now, this is a different kind. This is not a discrete function. This is the first one we've looked at where we don't have a finite set of values for the domain and the range, right? Now, how many x values are there in the domain there? How many? Infinity, yeah, right? There's an infinite number of points. You can think of a function, whether it's a straight line or a curve, you can think of a function as being like think of it like a, you know, like a beaded necklace or something, right? And we've got this piece of wire, and then there's an infinite number of beads strung on that wire, but they're just infinitely small, right? Each bead corresponds to a point on the function, an x and a y coordinate. So there's an infinite number of them. Obviously, I can't list them in this case. You know, I can't list them all because there's an infinite number. So what am I going to say for the domain this time? Okay, so if I want to use interval notation, I could write it like what? Okay, good. Negative infinity to infinity. That's our way of saying all reals, right? Using interval notation. Okay, what about the range? This would be all the y values. Negative infinity to infinity, right? Same thing for this one. And once again, that's our way of saying all reals. And of course, that is a function because it passes the vertical line test. Okay, let's try another curve that's a little bit, we can skip these. You guys know those. That's no big deal. Let's try these. Try some that are just a little bit tougher maybe. So what about this guy here? What's the domain of this one? Okay, so if I want to write it using interval notation, it's going to look like that. Okay, does that make sense? We want to think about this in terms of like if an ant were walking on this function, you know, what are all the x values the ant could step on? Well, the ant can walk to the right forever. Agreed? If the ant is walking along this function to the right, I mean, he's moving down, but he's also progressing to the right forever, right? If he walks up this slope here, he's going up, but he could also go to the right forever because that extends infinitely, right? However, there is a limit to how far he can go to the left. This is the leftmost point the ant could stand on, which has an x-coordinate of negative 4. Okay? Give me 1 to 5 on that, on the domain. Okay? All right, what about the range? What's the range going to be? Negative infinity to infinity, right? Because it can go from negative infinity at the bottom all the way up to positive infinity. He's taking kind of a weird course to get there, but because these arrows extend forever, there's no limit to how far down or how far up he can go. So if we wanted to write those using inequalities, this one would just be x is greater than or equal to negative 4, and this one would just be all reals, right? Is it a function? It's not, is it? There's a bunch of places here. We'll just take this one as an example. There are some points that line up vertically. So it's not a function. Okay, obviously this is not a function, but I want to know the domain and the range. So everybody talk this over with your neighbor. Let's come up with a domain and a range for this one. And I want you to, okay, so here's your task. You and your neighbor, you can work with 2 or 3, I don't care. Neighbor, you can have 3 in a group, 4 in a group. But I want to know what are the domain and the range written as inequalities and written in interval notation. Okay? So put your heads together, see if we can come up with that. Okay, what do you think? What'd you come up with? What's the domain? Okay. Give me thumbs up if you agree, thumbs down if you disagree. Okay, good? All right. So x is greater than or equal to -2 and less than or equal to +5. Good. And I would just be using brackets -2, 5, wouldn't it, in interval notation? Okay. I don't think I even need to do this, but one interesting way to think about this that's kind of nice for later on in math is to use the concept of a projection. Okay, so the domain is the projection of this function onto the x-axis. Okay, let me just explain that. Now, like I say, you probably don't even need this tool, but later on it'll be handy. So what if we took all the infinite points on this circle or ellipse or whatever that is, and we were just to squeeze them all down onto the x-axis? So their x-coordinates stayed the same, but we were just projecting them so their y-coordinates all shrunk to 0, right? For example, this point right here would just get projected down to there, right? And this point right here would get projected up to there, right? What would it look like on the x-axis? Wouldn't it look like this? Wouldn't it look like that interval right there if I projected all the points onto the x-axis? Okay, that's a graph, of course, of the domain then, right? Okay, what about the range? What's the range here? Somebody, give me somebody new here. Somebody, be brave. Be brave. We got to get over the shyness in here. We got to be brave. Okay. Bracket -2, 4. Good. Okay, so another way of saying that. Now, how would I say that is an inequality? Okay, so y is, I'll start in the middle. Y is greater than or equal to -2 and less than or equal to 4. And you caught the y. A lot of times people use an x there, but if we're going to write it as an inequality, it has to be a y, doesn't it? Good. And that would be the same thing if we projected this whole thing horizontally onto the y-axis. That would be my graph of the domain. Okay, you guys are getting this. You pick this stuff up fast. How about, okay, what about this one? You're going to get some problems like this. Now, for now, you can just use Desmos to do the graphing, because we haven't really reviewed how to graph quadratics and things. So if I were to graph this on Desmos, does anybody know what I'd find, first of all? What would that look like? Do you know? No? Y equals -x² + 3? What shape is it going to be, do you know? Okay, yeah, it's going to be one of those shapes. What do we call those? Remember? Kind of a U shape. Parabola, right? Quadratics. So it's going to be a parabola. Anybody know where the vertex is going to be? 0, 3. Good. Good stuff. So 0, 3 is the vertex. Does it open up or down? It opens down. Good. Good. Okay, if you didn't get all that, don't panic. We're going to review that stuff. But so that's what it looks like. It's a parabola, U-shaped parabola that opens down forever. And so from that, we should be able to determine the domain and the range pretty easy once we get the graph, right? Later on, after we practice graphing these functions and working with transformations of functions, which we're getting to pretty soon, sometimes we can even just not even do the graph, but we can just think in terms of what the graph is going to look like and get the domain and the range just by thinking about what it must look like. The domain's easy. What's the domain going to be here? All reals. Everybody agree? There's no limit, and there's a couple ways to think about that. If we think about that in terms of the graph, we know that as the function plunges down, it's going to go to the left and the right forever. Agreed? If I zoom out far enough, there's no x value that would not be graphed. Okay? So that's one way to think about it. I'm just going to write it using interval notation. Okay, the other way to think about it is this. Are there any x values that I could not input into that function? When would you be unable to input an x value into a function? What are some rules that you couldn't break with real numbers? Can't ever divide by, say it again? What number can I never divide by? 0. I could never input a value of x that would somehow cause me to divide by 0, right? I'd have to exclude any of those numbers from my domain because we can't do that. That's forbidden. What's another one? We can't take a square root of what kind of number? No, square root of a prime's okay. Square root of 7 is just the square root of 7. Can't take a square root of what kind of number, though, and get a real result? Now, I can even do that. I could put pi in. Square root of pi is just some weird number, but it is a number. Negative, right? Can't take a square root of a negative number and get a real output, right? Square root of -4 is, it doesn't work, right? Because think what that means. The square root of 4 is 2 because 2 squared is 4, right? So the square root of -9 is what? Nothing squared, no real number squared is -9, right? Every real number squared is non-negative. Non-negative means it could be 0 or it could be positive. Square root of 0 is 0. Square root of any positive number is positive, right? So it can't be negative, but none of those rules are being broken here. Everybody see that? There's no reason for us to be worried. There's no red flags that go up. So just by looking at this function, we can see I'm not breaking any rules. So the domain should be everything. And it is. It's all reals. What about the range? That's a little trickier. With the range, we kind of do need the graph, or we need to think in terms of the graph. This function has a maximum, right? It has a highest possible value at y equals 3, and it goes down forever. So from the graph, we can see that, can't we? Okay? This one, well, what you can tell me without even graphing it, this is what kind of function? What's that graph going to look like? Y equals -5x minus 1. Is it a parabola? Is it a cubic? Is it a line? Is it a, what is it? It's a line, isn't it? What's the slope of the line? Yeah, but what's the slope of the line? -5, right? So is it vertical or horizontal? No, right? It's got a slope to it. Any line that has a slope, isn't that going to cover, I mean, if you go far enough in either direction, you could hit any x or y value then, couldn't you? Right? So this is just all reals and all reals, right? Without even really having to graph the thing. We can see that. Okay, what about this one, though? What about the line y equals -7? What kind of line is that? Yeah, straight horizontal line with a y value of -7. So 1, 2, 3, 4, 5, 6, 7. So right there. Okay, so what's the domain of this one? Say it again. Negative infinity to positive infinity. So we'll just say all reals, right? All reals for the domain. What's the range? -7. It's only got one value, doesn't it? Right? So the range is -7. One way you could also write that is the set -7, but that's fine. You could just write the number -7. Okay? But it's only got one value. Is it a function? Yeah, it is. Passes the vertical line test. What about this line? X equals -1. What's that look like? Good. Vertical line at -1. What's the domain? -1. Range, all reals. Function? No. Okay, what about that one? Last one we're going to close on. So if I graph this in the xy plane, could you guys remember what that graph looks like? X is greater than 2. Do you remember how to graph those things? How we graph an inequality in the xy plane? We get a boundary line and a shaded half plane. Do you remember that stuff? Okay, well, we'll review all that stuff. But I just wanted to throw one of these at you. So this is all x, so all this is telling us y could be anything, but the x has to be greater than 2. Well, then the boundary line is the equation x equals 2. But we're not including 2, so it's a dash boundary line. And we're going to include all the values that are where x is greater than 2. Well, when x is greater than something, it means to the right of. And so we're shading in everything out here. So what do you think? Is that a function? No, clearly not, right? Because there's an infinite number of points that line up vertically. Okay, we'll come back and revisit that one again. That's like, we haven't really reviewed that stuff, but I wanted to just throw that in. All right, have a great weekend. That should get you through the assignment. I'll put the assignment up right now. You can work on it a little bit this weekend. It'll be due Tuesday, so you got time for questions. Okay, good. All right. Yeah, that's fine.